In the last lecture, we wired up our sign up form with the backend, so we're able to create users. Now I want to make sure that I'm able to sign in users. As before, I'll start with the backend before I then wire it up on the front end. So in the user.js file in the routes folder, where I currently have my sign up route, I will add a new route, which will be a post route, and here the path should be /sign-in. So in the end, of course, it will be user/sign-in. Here again, we get the callback you already know and love. And in here, how do we sign a user in? Well, the goal will be to find the user first, to identify the user by the email the user who wants to log in a browser provided here in our sign-in form. And once we found a user who fits this email in our database, we need to compare the password of that user in our database with the password the user entered in our sign-in form. So let's start by retrieving a user by email. I can use my Mongoose model for this, and here we get the find_one method, which does what the name implies. It finds all fitting entries, but then it only takes the first one. And this is fine, since I know that for each email address, I will only have one record, since email is configured to be unique here. And therefore, there is no need to fetch an array of users, which I then have to, extract, or where I then have to extract the first and only element if I know it will only be one. This is why I use find_one. Well, what I do here then is I pass a JavaScript object as an argument. Here I define the criteria by which I want to find an entry. The criteria, of course, is the email field in the database. And here I want to find all entries, or the single entry, where the email is the same email as passed in my request body here. So I will pass the email from the form in the request body, since it is a post request, and then I retrieve it here to match any email address in my database. Now here in the callback, we'll see if we were successful in retrieving a user. Let's first check if we get an error, in which case I use my standard error function or if statement here. But thereafter, I want to check if we, didn't have an error, but maybe we didn't find a user. So here I will check if user is, not existent, so if it basically is null. In which case, I also want to return a response where the status is also 500. But I will issue another error message. I will say title, no user found, and then issue an error, which is an object where I have a message which says user could not be found. Now here's an important thing. If you do it like this might create a security issue, because people are able to simply try out email addresses and you tell them no user found if the email address is wrong, whereas in the case of an invalid password, you would probably, give a message like password invalid. This way, people are able to figure out if they have the right email but wrong password or not. Now, to prevent this, a better message here is login failed, something like this. A generic message where you can't tell if the email or the password or both was wrong. So you can here issue invalid login credentials as a message, for example. So after checking for errors and if we don't have a user, we're now at the point where we know we do have a user fitting this email address. Now we have to make sure or to check if this user actually has the password the user on the client, on the browser, entered into the sign-in form. For that, we need to compare passwords, and that is where we face a problem, because we do encrypt the password here when we create a new user. As you saw in the Mongo shell, it's a really complicated string, and as I mentioned in the user sign up video, we can't decrypt this password. We can't get the plain text password from this encrypted string. This on one hand makes it secure, but on the other hand, how can we now figure out if the correct password was entered? Well, the bcrypt package we used for encrypting also is able to check if the password entered here in the login form would give us a hash, not similar to the other one, but comparable to the one in the sign up method. Since it is the same algorithm, we can basically see if the hash, whilst it is not the exact same, does have the same similarities kind of. So if we do have a valid password, and while this might sound strange, it basically comes down to this encryption algorithm where we can check if the same algorithm on the same password, whilst not giving us the same encrypted string, would lead to a comparable result. So this package, bcrypt, can check this for us. The usage is to again use bcrypt here and then call the compare sync method. Here, as a first argument, we pass the string we want to compare, so this password entered into the login form, which we can retrieve from our request. So request body password, and then the hash to which we want to compare it. That, of course, is the password stored in the database, so on the user we retrieved, here the password field. Now this will return true or false, and then we can go from there. So here I will check if this is true, so if it is valid, or if it is not valid. I will first check if it is not valid. So if not bcrypt comparison, so if this returns false, if the password is not the same as in the database. In this case, I want to return the same status as up here, though I just recognized we should return 401 as a status code for unauthorized here. And I will return the same error message for the reason I just explained, to not give a clue on whether the email was wrong or the password or both. So this is the case that we're not passing the right password, we're returning this error. Now if we made it to this point, we know that the user does exist and that the right password was entered. So now we should create this token I was talking about in one of the first lectures in this section. This token which our client then can use for future requests to tell us, hey, I already logged in, I am authenticated, please let me in. So this token needs to be created. And as with creating the password and comparing it, we won't do this on our own since we need a kind of complex algorithm behind that. There are packages to do this. The question in the first place is, how does such a token look like? And I will use a JSON Web Token, short form JWT. You can learn more about JWT, about JSON Web Tokens, by, as dumb as it sounds, simply Googling it. There are plenty of resources diving deeper into it. Basically, the first link here is a great resource. It is a token which looks like this, for example, which encodes a couple of information pieces in this token. Some header data, then the payload. Here, for example, we can store the logged in user, and then a signature we need to verify this token, including this secret you see down here. We will set this on our own. This verification signature here allows us to later on verify if the token passed by the client is a valid token or some arbitrary token passed by malicious code, for example. So this is how such a token looks like. And again, we will use a package to create this token. So which package do I want to use here? I'll quit out of my build process, and then I will install a new package by running npm install --save to store it as a production dependency. And then the name of the package I will use is JSON Web Token, like this. This will pull down the package and install it in my project. And once it is installed, I can pull it into my user.js file here. I'll store it in a variable named JWT, require JSON Web Token here. And then down here at the bottom, I can create a new token, store it in a variable, by running JWT sign. This creates a new token. It signs it for us, generates it and signs it. Now the arguments we pass here is the payload we want to store in the token, then this secret we need for verifying the token, and then some possible options. Now let's start with the payload. The payload is a JavaScript object that allows us to state any data we want. Here, I want to store the user in the token so that I'm later able to retrieve the logged in user from the token being sent to the server. So here I will set up a user field. This name is totally up to you, but you will need to use this same field name later when accessing data in the token. And then the value I want to store here is the user object I retrieved here, so which I found in the database, and of which I now know that it is valid, that the password is right, and so on. The second argument is your secret key, and this should probably be a bit of a more complicated string, but I will simply use secret here for simplicity reasons. And then you can configure this token. Now I will configure the expires in key, which allows me to specify how long this token will be valid. I will set this to 7,200, which means 2 hours, since this is measured in seconds. With this, the token is created. The final step is to now pass this token to the client. So I will set up a response with the status 200 here, and then some data to be passed with the response. And in this JavaScript object, I do pass a message like successfully logged in, whatever you want. Then I will pass the token in a field named token. And I will also pass the ID of the user ID. Why? Well, you will see this in a second when I hook this up to the front end. Well, this will basically allow me to find out the ID of the currently logged in user, and therefore on the front end to show if a user should be able to delete and edit a post, because I want to restrict this to posts of the user who is logged in. But you will see this in action soon. So here I will pass user_ID. With this, we're set to go. We're ready to wire this up to the front end. The backend is prepared. Time to now also go to the front end and submit our login form there.